Minute Math. When you need help, you use Minute Math.
Hi, I'm Sean Gannon, and this is Minute Math. And today we're going to talk about variable and verbal expressions. The difference of 10 and 5. 10 and 5. The difference between 10 and 5, we're talking about the separation between the two. How far apart are they? So the difference between 10 and 5, I'm going to start with 10, and I need to take away 5 from it. So that this expression here will give us the difference between 10 and 5. The quotient of 14 and 7. I want you to take a moment to think about how you can write that as a variable expression. So we're given the verbal expression. We want to translate that into a variable expression. Well, the quotient, meaning division, right? Division of 14 and 7. 14 comes first in that statement. So we put it on top, 14 over 7. Again, that symbol here means division. So we're given the quotient of 14 and 7. You decreased by 17. As soon as I see decrease, I should be thinking about subtraction. Decreased, subtraction. So if u is decreased by 17, we're taking whatever u is, okay, whatever u is, and we're subtracting 17 from that. So we subtract 17. So whatever that value that u is, we're subtracting 17. U came first. U decreased by 17. U decreased by 17. Half of 14. So if I was given half of 14, so if I think about half, I want to think about what symbol comes to mind. When I think about taking the half of something, that's essentially like division, cutting something in half, okay? Dividing it by 2. That's the key, dividing it by 2. So we start with 14. That number 14 is cut in half, divided by 2. Our symbol for division here, 14 over 2. And now we're taking the number 14 and we're cutting in half. So half of 14 can be written as this variable expression, essentially, of 14 over 2. We take that verbal expression, half of 14, and we're taking that half here, divided by 2 of that 14. So 14 over 2. X increased by 6. So x is increased by 6. Okay, when I'm thinking about increasing, I think about something going up, getting larger. Okay, so which symbol goes with increasing or increased? And I'm thinking addition. So I take the variable x. X is increased by 6. So we take x, we're increasing it, we're adding 6 to it. So whatever that x is, our variable, we're adding 6 to it. So here's our verbal expression right here. And then we can convert that increased right there. 6 comes down, x is here. So x is increased by 6. And this is our variable expression. The product of x and 7. Immediately I'm thinking product, I'm thinking of a symbol and operation, and that is going to be multiplication. So I take the product of x, so x, the product of x and 17, and 17, not 17, 7, product of x and 7. Now, product, when I'm writing multiplication, I'm going to use a dot here, using that dot there. And the reason why I'm using a dot instead of an x, okay, because imagine if I put an x there. If I had written, x times 7. It's getting confusing between multiplication and then x, so I don't recommend this. Another x in there, right? I want the dot there, x and 17. So the product of x, keep saying 17, of 7. The product of x and 7, 7, 7. Okay? So a product of x and 7, we have the verbal expression written right up here, and then we have our variable expression written right below it. The sum of q and 8. So immediately I'm seeing sum. That should trigger into my mind here addition. The sum of q and 8. Q is written first. So the sum of q, addition, that's where the sum comes in, right? Right there, that's sum. Sum of q and 8. So again, I'm writing the sum, q, coming down here. Let's bring it this way. There's the q, and then there is the 8. We start with our verbal expression, the sum of q and 8, and we convert that to our variable expression, q plus 8. Again, the key thing here, knowing that sum is addition. 6 squared. So I'm taking 6 squared. Now this is a tricky one. All right, what symbol is dealing with squared? Squared, squared, squared. I'm thinking about taking the number 6, and when I square it, I raise it to the exponent, to the power of 2. And that's the key there. I take a 6 here, and that's squared. I'm squaring it. A square is taking it to the power of 2. Now, a common thing I see is I'll see students take 6 squared, multiply it by 2, and then they'll simplify it and they'll say it's 12. That's wrong. That's multiplication. That is not squared. 6 squared is 6 times 6, which is 36. So if I take this verbal expression of 6 squared and I make it into a variable expression, I take 6 and I square it, put the 2 up top into the exponent of twice the letter q, so twice q, and I wanted to convert that into a variable expression. I would think, okay, twice. If something is twice as large, maybe as something else, twice as big, I would think of the number 2, twice being 2. So twice q would be 2q. Now you don't need to put the multiplication there in between, you can, but generally you won't necessarily write it like that. Maybe 2q, meaning 2 times q. So that's our verbal expression, twice q. And I can move it, translate it into a variable expression of just the number 2q. So twice q, 2q. Think twice to be the number 2. The product of 8 and 12. So if I was given the product of 8 and 12, okay, the product of 8 and 12, I would rewrite that as a variable expression by taking apart what was written up here. The product, the first thing I think in my head is multiplication. So I'm thinking multiplication, the product of 8 and 12. Well, 8 comes first, so 8 and 12. So I'm thinking about the product of 8 and 12. So the 8 comes out here. The product, kind of mix with that and here, combine the 2 there, and 12. So the product of 8 and 12 is the variable expression of the verbal expression written right up here. So 8 and 12, 8 times 12, the product of 8 and 12. The quotient of 18 and n being that variable, the quotient, I should be thinking quotient of division. All right, so I'm given the first number being 18, so 18 divided by n. So the quotient of 18 and n can be written as a variable expression as 18 over n. 18 divided by n. Quotient divided, quotient, divided, quotient, divided. That should be ingrained in your head when you're thinking about it. Whenever you see the word quotient, you should be thinking of division. Of n cubed. N cubed. I'm thinking about the variable n, and I'm cubing it. So I start thinking about, okay, cube, cube, cube. All right, cube. That's going to be some exponent. Cubed exponent is 3. So I'm going to start with n, and I'm going to raise that to the third power. So cubed, you should be thinking about 3. The way I try to remember it, a cube is in the third dimension. That's a way to remember it. So cubed is 3. So n to the third power. So I have my verbal expression, n cubed, and I can write it as my variable expression as n to the third power. X over 2. And I want to write this as a verbal expression. So I'm given the variable expression, x over 2, and I'm going to write that as a verbal expression. Okay? So what are we doing? We're taking x and we're dividing it by 2. We're taking half of x, right? Divided by 2 is half of x. So we have half of x. So x over 2, x divided by 2, that division, I should think, okay, dividing, what are we doing? Oh, we're dividing by 2, cutting something in half. The verbal expression is half of x. A plus 9. I'll say a plus 9, and I want to write that as a verbal expression. So I can write that by saying a increased, right, increased, addition, adding, increased by 9. So we're taking a, we're increasing it by 9, whatever that is, 9 units, whatever it's going to be. We're taking a and increased by 9. Increase matches up with plus, right? A increased by 9. If I'm given 19 minus 3, and I want to write that as a verbal expression, how would I do that? Well, I have a minus sign here. That minus sign makes me think about the difference, okay? The difference. That's one of the key words of minus. So the difference of 19 and 3. So the difference, being subtraction, the difference of 19 and 3 takes that 19 subtracted by 3. So that subtraction, again, is bringing that difference. That's what we're looking at, this difference with that subtraction. 5n. 5n. And I want to write that variable expression as a verbal expression, okay? I have the number 5. Now look what's in between here. Really, that 5n is 5 times n, right? So 5 times a number. Okay. Now I would write 5 sometimes, 5 times a number n, whatever it is. But in this case, n as being any number, it's 5 times a number. Right? So we have 5 times n, right? And representing that number, so 5 times a number. The letter Q with a 2 up top, 2 in the exponent. Okay? That exponent, that 2 is an exponent, if we remember, that is referred to as squared. Okay? Whenever there's 2 in the exponent, that's squared. So this one's pretty simple. It's just Q squared. Okay? The way I like to remember squared with the 2 is I think 2, okay, squares are in the second dimension, if you think of it like that. They're 2D objects. And so we have squared with a 2 up top. So the 2 in the exponent means squared. So Q to the second power is Q squared. The number 40 on top of the number 5. Now we see that fraction, that 40 over 5, that fraction is division. We're taking 40 and we're dividing that by 5. So with that same verbiage, we're looking at it, 40 divided by the number 5. So we have 40 over 5 is 40 divided by 5. Remember that symbol here, that symbol right there is that division. Right? We're dividing by. So we take 40 and we're dividing by 5. The letter A over the number 8. So we have A divided by 8. Well, that's really what it is. A divided by 8. That right here means the division, right? 8 divided by 8. The fraction A over 8. A divided by 8. We are taking that variable expression, the top part here, that variable expression, and writing it as a verbal expression using words. The letter X plus 8. Well, we have X plus 8, right? We're in addition here, right? X added by 8. We can really write it as X plus 8. Fairly simple. That plus sign right here, right? We just write the word plus. So we have X plus 8. Again, we take that verbal expression and convert it, variable expression and make it into a verbal expression. N minus 14. Okay? So n minus 14, we're going to take a number, n, right? A number minus 14. Pretty simple. N minus 14. N refers to a number, whatever that number is, we don't know, minus subtraction, right? That minus subtraction, another word there, 14. So a number minus 14, n minus 14. Again, taking that variable expression and writing it as a verbal expression. The number 2 to the exponent of 2. Now this one's tricky, right? Because we see two 2's, right? Two 2's, and it's 2 raised to the second power. Well, what's another word for a second power? That's going to be squared. So we're taking 2 squared. So we're raising 2 to the second power. That is our exponent. This here refers to the squared, and this 2 here is that 2 right out front. So we have 2 squared. We're taking that variable expression and writing it as a verbal expression. The number 60 over the number 5. Right there, I'm seeing 60 divided by 5, 60 over 5. I can write this, well, instead of writing divided by 60 divided by 5, I can use another word, the quotient, right? Quotient meaning division, okay? So the quotient of 60 and, I'll write down here, 5. The quotient of 60 and 5. Actually, I'll put this right here to the side. 60 and 5. So the quotient of 60 and 5, 60 came first, and 5 referring to these two numbers in that order from top to bottom. So the quotient, meaning that division, of 60 and 5. We took that variable expression and wrote it as a verbal expression. N, multiplication, 6. Well, I think that number n, right, a number, that n can represent any number. So I have a number. Well, another word for that multiplication, that little dot that's inside there, multiplication. Well, that's times, right? N times 6. N times 6. So a number times 6. So we have that variable expression converted to a verbal expression down here. Variable n times 6, variable a number times 6. Five squared. 5 squared. Okay, think about 5 squared. Well, in my mind, I'm thinking that's 5 to the second power, right? 5 times 5. Okay, so 5, right, 5 squared, okay, 5 squared, 5 to the second power, oh, that's 25. So I'm evaluating that verbal expression right here. And in my head, I'm thinking about that 5 squared, what it looks like, okay? 5 to the second power. And we're going to practice without doing that, writing it out. But sometimes you might need to see it, see it written out there. But really, that's what's happening. 5 squared, 25, where you evaluated that verbal expression to get the number 25. The product of 8 and 10. So right when I see a product, I'm thinking multiplication, right? Multiplication, that little dot, multiplication. So the product, the multiplication of 8 and 10. Well, what is 8 times 10, right? 8 times 10. Well, 8 times 10 is 80. Fairly simple. So the product of 8 and 10 is just going to be 80. So we took that, the expression, the verbal expression, and we came out with solving it. We evaluated that to get the number 20 decrease by 17. So 20 decreased by 17. So we take 20 and we're decreasing it by 17. Well, it decreased, I should think about subtraction. So I'm taking 20 comes first, 20 minus 17. So 20 decreased by 17. Well, 20 minus 17 comes out to be big 3. So 3 is our answer. We have that expression here, that verbal expression that we are evaluating. 20 decreased by 17, 20 minus 17, which is 3. The quotient, and if you listen closely, you can hear my cat in the background, of 96 and 8. So the quotient of 96 and 8, okay? The quotient, I should be thinking about division here. 96 and 8. So the quotient of 96 and 8, 96 divided by 8. How many times does 8 go into 96? 96 divided by 8, well, that's going to be 12, right? So 96 divided by 8, the way I kind of do it is say, okay, 8 goes into 80 10 times, 8 goes into 60 2 times, 12. All right, 10 plus 2 is 12. That's the way I think about that, and that will be another video about how to do those tricks with math, okay? But for right now, we are evaluating each expression. We're given the expression, the quotient of 96 and 8. 96 divided by 8, and that becomes 12. So we evaluated that right here. Twice 6. Just twice 6. All right? If we have 6 twice, what would that be? Twice, twice, twice. Twice 6. Twice being multiplication by 2. So really, that's like 2 times 6. Well, 2 times 6 is just 12. So twice 6, that expression, the verbal expression, our answer when we evaluate it is that 12 right there. So twice 6 becomes that 12. 10 less than 17. 10 less than 17. So 10 less than 17. Now, this one's tricky. So it's 10 less than 17. So less than means subtraction. And here's the tricky part. We're taking 10 less than 17. So 17 really is what's coming first. We're taking 10 less than that 17. So it becomes 17 minus 10. 10 less than 17, 17 minus 10, which is just 7. So if we take 10 less than 17, we're taking that 17, taking 10 from that, 10 less than that, which gives us 7. So here's our verbal expression that we're evaluating, and it becomes 7. 9 times 5. So we're taking 9 and we're timesing it by 5. This is our verbal expression, and we want to evaluate it. What is 9 times 5? Well, 9 times 5, 9 times 5. Can you remember off the top of your head? 45. So we have that verbal expression that we're evaluating here, times being multiplication, so 9 multiplied by 5, which is 45. I was given this expression, 10 increase by 8. So 10 increased by 8. We're going to take 10, we're going to increase it by 8. Well, 10 increase being addition by 8, 10 plus 8, 18. So 10 increased by 8, we're taking that increase, realizing that that's addition, right? Increase being addition, we get 18. We're taking that verbal expression, evaluating it, and making it into 18. So 10 increased by 8 is 18. 7 squared. 7 squared. We're going to take 7 and we're going to square it, okay? So 7 squared. Well, I'm going to look at that, thinking squared, okay, 7 squared, squared. That's a 2 in the exponent. So 7 is my base, 2 is in the exponent, but decent looking 2, 7 there. 7 squared, 7 to the second power, and that 7 squared is really 7 times 7. Well, 7 times 7 is at 49. 49. So we have 7 squared, 7 to the second power. That's how we can evaluate that, or write it as a variable expression. We evaluate it, we get 49. So we're evaluating that verbal expression. We got 49 because 7 squared is 49. The product of 4 and 5. So the product of 4 and 5. Well, product I should be thinking about is multiplication. Multiplication. So I have that multiplication here. The product of 4 and 5. So we have multiplication of 4 and 5. The product of 4 and 5. So 4 times 5 is, think about it, 20. So the product of 4 and 5, 4 times 5 is 20. We have that verbal expression. We converted that to a variable expression, and we evaluated it to be 20. Going down here. So the product of 4 and 5 is 20.
Minute math. When you need help, you use Minute Math. Minute math. When you need help, you use Minute Math. MinuteMathTutor.com.